I'll take you for a ride on the devil's ship. I'll take you for a ride where you sink or swim. Now come with me and let this story begin.
David Weiss is here, so we're going to talk about the flat Earth. But if anyone's listening on Spotify or anywhere, I recommend going to YouTube because we do have video of it. So there you go, David. We covered that.
Nice.
Okay, so let me ask you a question. When did you get it? Like, how did you? When did you get into the flat Earth?
You know, I woke up one morning, I go, my life's going pretty well. I think I'm going to come up with a concept that will alienate me from every single person I know and my family and, and just make me be ridiculed. And I just figured that would be the greatest way to start my day.
What year did you get into, what year did you get into it? Is it recent?
No, like 2015. So this is how it happened. I did a podcast called Deep Inside the Rabbit Hole, and we looked into all sorts of conspiracies, things that deceptions in this world, and there's plenty. And then people started sending me, "Hey Dave, have you looked into flat Earth?" And you get that, it's like delete. That's a joke, flat Earth, dumbest thing ever. And they kept coming. They kept coming and coming and coming to the point where I started banning people from our social media for being so stupid to even ask such a question. And then I was forced to look into it because another researcher said, "Dave, I think the Earth is flat." And I'm like, "Nah, you too." And she goes, "Here, watch this." And she sent me over Mark Sargent's clues. I don't know. You might have heard the name Mark Sargent if you looked into flat Earth at all.
No, I never looked at it. It sounds, I'm going to tell you, it sounds completely ridiculous to me.
Yeah. Well, by the end of this conversation, you're going to be like, the ball sounds a little ridiculous. I'm going to say some insane things today. I'm going to say some things you're going to go, that makes sense. The insane things are about the heliocentric model, the ball model.
Okay, right? Let's see.
We're going to get into it. We're going to have a good time.
Yeah, I'm fucking psyched.
Don't believe anything I say. Don't believe me. Just go, I never looked behind that door. Now I got to go verify that. Right?
I'm a bit of a dummy, but I am a man of math. Like, I like things that make sense.
Beautiful. We don't live on a math equation. Just remember, we'll start off with that. So Mark Sargent, I got the Mark Sargent clues. Basically, same thing happened to him. So he made a series of short videos going, "Hey, this is really weird. How does this work on a globe?" And he put out these short videos expecting some PhD, some scientist to get back to him and go, "This is how it works, dummy." But no one ever got back. And then the whole thing started going. So that I tried to disprove flat Earth. I tried to prove the globe and disprove flat Earth. And that's how you become a flat earther. So where do you want to start?
Okay, so where does the thought of modern day flat earthism start? Because I had a friend here, he was a comic, and then he left and he started, I believe, a flat earth community. Matt Powerland, his name is now.
Powerland, yeah. Matt is one of the OG, he's the guy that started questioning it first.
Very good painter, but again, the flat earth I find ridiculous.
Well, that's because you don't know anything about it, and I thought it was ridiculous too. By the way, I'm not picking on you at all, but I was you. I was everything you're going to say, I was. And then after looking into it, every culture before this time was a flat earth culture, except when the religious cult of NASA came in.
Well, no. Remember, I'm Greek. We still had thousands of years. We still had Atlas holding a globe. We were counting the circumference.
That's what you were told.
Yeah, okay.
That's what you were told. Here, let's just jump right into the Greek.
Yeah, let's do it.
We had Aristophanes with his sticks and shadows experiment. Do you remember that?
Well, I wasn't around, but I know what you're talking about. Yeah.
Well, this is what we're taught. We're saying,
yeah.
And Carl Sagan brainwashed us with it. That the only way that he could be here in Said, where he had no shadow because the sun was directly over him, and his buddy 500 miles away had a shadow, and then they did some calculus, perfectly good math, and figured out the circumference of this ball, right? And the math is perfect. The problem is they're assuming that the rays of sun are coming in parallel when that's not how they come. And on a flat Earth, the sun is small and close, and he could be right here. His buddy 500 miles away. You can take these angles, do the same math, and figure out the sphericity of this flat line. So,
but you could
both models.
Let's say it works on both models. So, where on the flat Earth? Where's the sun?
The sun is small and it's close and it's circling over the flat Earth. So then the next question you're going to have is, where does nighttime come from? So, if this is the flat Earth. The sun, here's the sun, and it's circling around. It's small and it's close. Don't ask me how big it is or what it is. We'll get into that, but we're gonna prove.
And what's the other thing? A moon?
Yeah, the other one's the moon. This happens to be a full moon model where the moon is full, and I'll show you how the phases work and how that works in a little bit. But we got to cover some basics.
Yeah.
First. Okay. So when you think of flat Earth, when you Google if you Google flat Earth, you're not doing research. You're doing unresearch. You're doing what the mainstream wants you to do. You Google flat Earth, you're going to come up with pictures like this.
I never Googled it. Yeah, this is amazing.
But if you do, this is what you end up at. These images are from the Flat Earth Society. You may have heard that because Obama mentioned it a half a dozen times in speeches.
He mentioned the Flat Earth Society.
He goes, we don't have time for a meeting of the Flat Earth Society. Okay. Right? And that's the way they ridicule it. And then anyone like, oh, let me search Flat Earth Society. And
but you do see how crazy it does seem, right? Like when we're talking about ridiculing it, like you see how crazy, if you just tell someone, hey, the Earth is flat, you see how crazy it sounds or no?
I know every single question you're going to ask because you've been programmed to ask.
Oh, shit. Okay.
Right? So before you ask a question, let me guess what the question is. I'm going to tell you what it is.
Okay.
All right. So no flat earther believes that we're a disc floating in space. That's insanity.
It is, yeah.
But that's what they want you to believe. So if the flat Earth isn't a disc floating in space, what is it? So the way I look at it is the Earth is like a pond, right? What is a pond? A pond is where water accumulates in the low spot in the land, right?
Okay.
And the edge of the pond is what? Where the land is higher than the water. We're going back before. This is Aristophanes had to assume all of these rays are coming in parallel. No one's ever seen parallel rays coming in. They're always coming in at an angle. And if you connect those, where's the sun? It's kind of right above the clouds. So we'll get into that in a little bit. But so a pond is, where is the low spot, the shoreline of the pond is where the water, where the land is higher than the water. I'm looking for a picture while I talk, and of course it's missing. So a lake is just a bigger pond. And if you think about the world oceans, here we go. The world's oceans are just a giant lake. The shoreline of the lake is Antarctica. All of the continents, islands, whatever, are surrounded by water, but the water is surrounded by land. Antarctica is the highest land on Earth. Did you know that?
No.
We live in the Antarctic basin. Large bodies of water at rest lay flat. Scientifically, testably, provably flat. There is no curvature. So
I don't think that's right though.
It is right because we large bodies of water. We have sea level. We don't have sea curve. We can see things that are too far away. For example, they tell us the ball is 24,901 miles around. That's what they tell us. So if we use their math, at just 10 miles, there should be 66 feet of curvature. Just at 10 miles, according to their math. That's crazy. So we can go out and get our super zoom cameras and set them up on a tripod next to the edge of the water.
Right.
And we can see too far. Here's an example. 9.4 miles away. The camera's 1 foot off the ground. There should be 59 feet of curvature. But not only can we see the rig, we can see the water for dozens of miles beyond it. Right? This is just one that I can illustrate here.
But what about if it was moving? Like, let's say if it was a boat.
Well, so the boats disappear from the bottom up, right? That's your next question.
It wasn't, but that's a good point, yeah.
Yeah. So look out here. Is there a boat out here? I'm zooming in. There's no boat, but there actually is a boat. You just can't see it because it's too small. So I'm going to zoom all the way in on this boat.
Yeah, there's a boat.
And then when I zoom out, it'll be the equivalent of that boat going away. And watch the side of the boat. It's going to disappear from the bottom up. And that's due to angular resolution limits of your eyes. Look, the hull is gone. It's up to the window. And then the whole thing disappears. It's not over the curve. It's just beyond your ability to see because it's the way the angular resolution limits of our eyes work. So if you were standing right here,
and
I walked around that hallway, and I gave you a telescope, any telescope you wanted, I'll give you the Hubble telescope. Could you zoom in and see me again?
But that's also a smaller curve than what we're talking about. Though this is on a bigger scale.
I'm just demonstrating a curve. So if I flip that hallway sideways, this will be the curve of the Earth. If I was on the other side of that, you can't zoom in because there's a physical horizon here.
Yeah.
And no amount of zoom will do it. But when you look at this image here, we're zooming in and bringing things back into view. That proves that it's an optical.
But there must be a limit, right, where we can't zoom anymore because it's too far?
Well, yes, the air gets actually kind of thick, and then you can't see. So here's a famous spot. This is in Aluja, France, and it's a famous sightseeing spot because out here is Mount Canigou, 175 miles away. Well, from this viewing height and that distance, the peak, the highest peak of Mount Canigou should be a mile below the physical curve. If this was a physical curve, this is just what's called the vanishing point. And the light that's bouncing off of the mountain is not bright enough to push through the soup of the air because light doesn't go forever. They have us believing light travels for billions of years. Nonsense. Okay. But on 2 days a year, when the sun lines up with these mountains, as it goes by, it backlights the mountains and all of a sudden you can see them. And right there where the mouse is, that should be a mile below the curvature, according to globe math. So you have two options here. One, the Earth is 1,000 times bigger than they tell us, or it's flat.
I mean, I think there might even be a third option.
Third option would be refraction, but the problem with refraction is how does a mirage block the sun? Doesn't happen.
I mean, but in the night and day model that you showed me earlier, how does an eclipse happen? How do they overlap each other if you showed the moon on one side and the sun always on the other side?
Yeah, so you have the sun and the moon are circling in the sky above us, and they're in what we call the firmament. You're getting into some advanced questions here. You're asking great questions, by the way.
I'm just curious because
the moon. So here is this line is the Tropic of Cancer, and this is the Tropic of Capricorn, the outer line.
So you're saying that they go around the tropics?
Yeah, so the sun circles. Now, this isn't to scale or to speed, but the sun travels in between these tropics every 6 months, and the moon travels in between the tropics every 28 days. And when they hit a nodal point at the same time, they cross each other, and that's when an eclipse happens. Okay?
But aren't these...
And think about this.
Yeah.
The eclipses repeat every 18 years and whatever number of days. But they repeat. They're on a repeating cycle like a fine watch repeats.
Yeah, we could time it. We could tell when eclipses are going to happen. But what I'm curious about here is...
We know there's a series of eclipses that happen, and 18 years from now, the same series of eclipses will happen again and again for eternity. If you believe we're in a beehive, crazy orbiting, we're traveling trillions of miles a year. This is the heliocentric model. We're spinning at 1,000 miles an hour, orbiting at 66,000 miles an hour, chasing the sun at over 500,000 miles an hour. And that
we're orbiting around it too, right? So it's not like we're chasing it. We're orbiting around it too, right? Around the sun. So it's not like we're always trying to catch up and it's going faster than us. It looks like we're all propelled the same. But I want to go back because I'm curious about the Capricorn stuff you were showing. So
let me share my app with you. The app is the best way to see it.
Yeah. I want to see because what I'm curious. Okay. Oh, this looks simpler. Okay.
Yeah.
So those are the lines. The three in the.
So the inner line is the Tropic of Cancer. And I'll explain that in a minute. The outer line is the Tropic of Capricorn, and the red line is the equator. This red line is 24,901 miles around. Okay. So the sun, right now the sun is supposed to be pinned to the hour hand, but we're in daylight savings time. So the sun is really what time it is. They tell us it's an hour later than it is.
So here's what confuses me about what I'm looking at right now.
Go ahead.
So one thing is the light.
Yeah.
So it seems odd that light is going far on one side but not on the other side. Like it seems like what's blocking it in the middle?
Yeah, no, I got you. It's just the distance the light can travel, and there's.
But if it's a ball,
right now it's showing it that it's almost a straight. It's almost 50-50. But if I jump the sun in 2 months to June, you can see that the day and night kind of wraps around a little bit more, right? So,
but aren't those lines around? Aren't they different? The way it looks here, aren't they different sizes?
Absolutely, 100%.
But if they're different sizes, wouldn't that make the seasons different? Wouldn't that make like the time of day different depending on the time of year?
So let me. You're asking all good questions, but you got to listen to the answers because the answers are longer than the questions. So, right now, this is our summer. You're in the United States, right?
Yeah.
So that's and June 21st is the summer solstice, and that's the closest the sun gets to us. And when it's close, it's high in the sky, and we have these longer days. So right now, it's coming. Right now, it's dawn on the East Coast. And the sun's coming around. And when the sun's over here where my mouse is, it'll be noon for the East Coast. And it'll be really hot in Florida, in Miami, because the sun is directly over them. They're right under the Tropic of Cancer. A little cooler up in Connecticut where I am, cooler in Canada because they're farther away. Australia is having their winter at the same time because the sun never gets close to them. I'll jump the sun forward to December. And now we're having our winter, and Australia's having their summer because the sun is directly over them. Our sun is farther away south, so it's lower in the sky, and we're having shorter days.
But what about places that go with full daylight for months? What about spots in Antarctica or in Alaska? How does this account for that?
So good questions. Very good. Let me jump it back to the inner. So it's back over the Tropic of Cancer, and it's all has to do with how far the sun is from you to make it set. So here in Alaska and in Norway, these inner places in the Arctic, the sun never gets far enough away. Like if you're standing right here in Alaska, the sun's still up in the air. It's still up in the air. Following my mouse, it's kind of far away, but it's still up in the air. And you have your 24-hour sun in June for a period of time.
But isn't this a different model than the night and day one that we saw, where the moon and sun were opposite all the time?
No, that was just a one frame model. That was just showing you a full moon depiction. Like if I speed it up, watch. The sun will lap the moon once every 28 days. So the sun keeps track of the hours and the days, and the moon and its phases and its position keep track of the weeks. And they used to be called moons. There used to be 13 moons of 28 days, and then they changed it to 12 months of random days just to literally throw our body clocks off. So right now it's gaining distance on the moon, and the moon is waxing. And every 28 days, it will lap the moon.
Is this the real flat Earth map?
This is the closest map that we have because it's way better than the globe. It's used for navigation, and it shows you. I'll get into that in a second, showing you that plane routes prove that this map is the most accurate map that we have. So,
because if this would be correct, then wouldn't like Brazil or Argentina going to Australia be the longest flight?
Absolutely. Let me explain that to you. You're asking great questions. I can show you all of those answers. So let's just stick with this for a minute.
Yeah.
So here are the zodiacs, and the zodiac stars never change. You go out tonight, mark where the stars are in the sky at whatever time. A year later, same time, same night, go out. The stars will be in the exact same position. Right now, let me turn that off. Right now, the sun is in whatever tropic this is. Where's the sun? Here. And the zodiac laps the sun, not like it laps the sun once a year. So it's just going slightly faster. So right now the sun is moving into this zodiac. It'll inch across this zodiac for about a month, and then it goes into the next one for a month, and then it'll follow the next one, Cancer, for a month. And if I jump forward to June, we'll go July, and the sun is in the Tropic of Cancer. And if I don't
know enough about the zodiacs to dispute this, but I don't know enough about like the zodiac signs to dispute this.
Well, I'm just showing you why they call that the Tropic of Cancer and the Tropic of the Tropic of Capricorn.
But so let's say if it's flat. So I don't know if you could see me right now. So let's say this is this is the Earth. So technically, wouldn't we all be looking at the same sky?
No. Well, think about this. We're both in a room.
Yeah.
We're both in a room, and we're looking up at the ceiling, and and there's lights in the ceiling. Now we expand that room to 10 miles wide.
Okay.
make the big as a city,
Yeah.
and I send you 5 miles away from me, 10 miles away from me. Well, when you look up, you're looking at different stars, and I can't even see you because the ceiling and the floor have merged together, and I can't see you unless I had a telescope and I could zoom in and make you bigger. But when we look up, we're looking at completely different stars.
Yeah.
The lights in the ceiling are completely different in the outer southern hemiplane and the inner northern hemiplane. Real quick, let me get out of the
But
app,
wouldn't they see the same stars but from a different perspective?
Yeah, well, let me explain. So, if you're here in Santiago, Chile,
Yeah.
and you're looking up at the stars, I'll just turn these stars on.
Hey guys, I want to let you know that support for this podcast was also brought to you by Manscaped. The lovely people over at manscaped.com wanted me to let you know that the Lawnmower 3.0 is out. Manscaped is trusted by over 2 million men worldwide with their ball trim and health, and there's a reason. They're innovative. The reason they got the Lawnmower 3.0 is because they spent 18 months perfecting this ball trimmer. All right, so if you want to trust a ball trimmer, the Lawnmower 3.0 is the way to go. And there's a flashlight on it in case you're on the run and you got to shave. You're perhaps a predator or an athlete. Perhaps you like to drive and, shave. Who knows? But it's superior technology. The battery lasts about 90 minutes. That is an hour and a half. Now, look, I'm going to be honest. If you're trimming your balls for an hour and a half, you got other problems. Perhaps consult a physician. But maybe you just haven't had time to charge it. So it could be on multiple occasions where you're trimming. I'm just letting you know that this battery lasts really, really long. And to do you a solid, if you head over to manscaped.com and use the promo code Pantelis, they're giving you 20% off and free shipping. 20% off, free shipping, promo code Pantelis. Is there ever a better reason than 20% off to order ball trimmers? No, there isn't. Manscaped.com, promo code Pantelis, 20% off. Do it now.
The stars rotate around once a day. So when it's midnight in Australia, you're looking at the stars, and then 12 hours later, those same stars are over Santiago.
Right, but are the stars moving? Like what's happening?
Yeah, the stars are circling around, just like they should, just like you can see here. They're spinning around with the sun. So wherever the sun is, you can't see the stars. So right now, like Cancer is over Santiago, right? 12 hours later, Cancer will be over Australia. Because they're spinning around. Everything in the sky that we see spins around above us like a perfect clock.
Aren't we the ones that are spinning?
No, we're not moving at all, right? The time zones turn around with the sun. Wherever the sun is, it's noon. So right now as we speak, it's 2 a.m. in Eastern Australia. It's 6 p.m. in Central Africa. It's close to noon Central Time.
But that doesn't mean that we're not spinning.
No, we're not moving at all. I mean, here's the thing. Let me just show you one thing on the app.
Yeah.
I'm offering a Bitcoin for anybody that can give me one proof of the globe. And before you, what I say is every day there's a new video right here. Watch the daily video every day for 2 weeks. And if you still think the earth is a globe, hit the question mark and up come all of the questions that you can possibly ask. Like if you say, hey, what about eclipses? And you click that, up comes a playlist of videos that Google will not serve you. These videos they're up there, but they're hidden. Like if you search top 10 reasons the earth is a globe,
right,
you're going to get top 10 reasons the earth is flat. You're going to get a video that's top 10 reasons the earth is a globe because they don't want you seeing this stuff.
But why? What do they have to gain?
Yeah. So let's save that.
Okay, we'll save that for later. We'll save that for later. Yeah.
You asked a whole bunch of questions about I forget what the question was.
Yeah, you see, that's why I wanted to write them down. I told you I was going to have questions. Well,
Did you write them down?
I wrote a lot of them down here, but I mean, you showed me how the times work. Oh, so what I was wondering was because the stars do change, right? So the stars change over time. Like now, I'm on the northern hemisphere, so we'll use like our North Star is Polaris, right?
It never moves.
But it used to be Thuban. Right? They had a different one that they were looking at the ancient times.
Cool story, bro.
Oh, so you think it's the same star, different name?
So think about this.
Yeah.
It's the same star. They tell us that 40,000 years ago we had a different star,
yeah,
and in 40,000 years from now we'll have another star. But we just happen to live in the time where where the star is always in the exact same place. That, we're just in this time where Polaris has never moved, and the amount that they say it's moving in the last 70 years, it should have moved at least a degree, and it hasn't. It hasn't at all. Are you familiar with the Georgia Guidestones?
Is that those stones that write we need the population to be reduced to 500,000 people or some shit?
Right.
500 million?
Right. Yeah. So just remember all of these motions. We're traveling trillions of miles, okay? Yeah. But at the Georgia Guidestones, there's a hole, and if you look through that hole, it was built over 40 years ago. The North Star is through that hole. Time lapse, all the stars to go around it. How is that possible if we're spinning, twirling, and whirling and cruising in 4 different directions at once, and all the other stars in the galaxy are moving at their own directions?
Aren't they all moving at their own directions, but relative to us? So
how is that even possible? Think about it. We're orbiting the sun. We're 186 million miles on the other side of the sun in every 6 months,
but then we come back to the same points almost.
Yeah, but
relative to the sun,
still there. Once you actually think about it, and then the distance of those, we'll go over that in a second. But as far as you were talking about how long of a flight it would be.
Yeah. This I'm curious.
Yeah. So here is Buenos Aires, major city. Lots of people want to go to Perth, another major city.
Yeah.
This is the fastest route on the globe. But the Antarctic Treaty says we can't fly any planes over Antarctica because we could disturb the penguins. Okay. All right. So big deal.
But you don't need to fly over Antarctica, right?
Well, you could just fly around it. You could just fly around it like this, right? Boom. Or around this way. That would be the shortest way. But this is the actual route that they go. They go from here, they stop in Miami or Houston, then they stop in LA, then they stop in Sydney, and then they go over to Perth. Or sometimes they go all the way up to Europe, to Singapore, and to Perth. These are the actual flight routes.
Well, but there are South American flights that go from South America to Australia directly over the Pacific.
They don't. These are the routes. They tell you that it's going, like this one right here from Australia, from Perth to Los Angeles. This is where they would tell you. And NASA is in charge of all flight routes. But right out here where Hawaii
NASA's in charge of flight routes?
Yes. And they're in charge of radar. They're in charge of GPS and flight routes because it's all a deception. NASA is only here to get to your question of why are they lying. It's all about the lie. So right out here is Hawaii, and there was let me find the right image. There was an emergency where one of the passengers was having a heart attack or something was going on, and they needed to land the plane immediately. Okay. And the logical place to land it, here we go. So right out here, the logical place would be land in Hawaii or continue to LA, but they were right here. They went all the way up to Alaska and landed up there. Why would they do that? And the answer is Taiwan, emergency, Alaska. That's the closest spot. Hawaii is out here.
I don't know.
Well, no, just look at it.
I'm looking at it here, but I mean, I don't know what the story is. I don't know why they'd go to Alaska. I mean.
Well, they went to Alaska because look at the flight route. The emergency happened right here.
Yeah, it does seem convincing, and yet at the same time, I want to know more details about that story.
So here you go. This is how you do it. This book is free online, PDF, or if you want to order it from lulu.com, it's an awesome coffee table book. 16 different emergency landings that make 0 sense on a globe and make perfect sense on a flat earth.
But I feel like there's separate arguments, right? Because just because something would make sense doesn't mean that the other one doesn't. Because what I'm thinking now is other planets. Are we the only body that's a plate like this or that's a pond and the other celestial bodies are all globes?
So have you ever seen a planet other than from NASA or Walt Disney?
Only when I'm looking, we could see Mars and things like that.
So when you look up in the sky and see Mars, it's like the brightest star in the sky, right?
When you could see it, yeah. When you could see it, it's bright.
So think about this. The images that they show us from Mars. Now, if you're on Mars and you're looking at the sun, it's really small because you're much farther away on Mars than you are from Earth, right?
Yeah, it's further.
It's farther away, so you would say it's less bright. Wonder how solar panels somehow work there. So on Mars, this dusty, dirty ball is able to reflect sunlight back so bright that 25 million miles away, it looks brighter than a star. I'm sorry, that doesn't work. If you like math, look at the inverse square law of light. Every time you double the distance to something, it gets a quarter of the brightness.
Right.
Okay.
But again, now we're also not talking about the light that's reflecting. We're also talking about the light that we're seeing, right? So
the light that we're seeing, like when we see Mars, we're seeing the sunlight that's reflecting off of it. That's what they tell us.
Right, but it's nowhere near the same brightness as the sun or as the stars that we're looking at. It just looks bigger because it's the next planet over.
No, it's brighter than the stars. You can actually measure it with it's brighter than the stars. How is this thing reflecting light as bright as a star? Next time you go look at Mars, look at it. It's bright. It's brighter. It's bigger and brighter than all of the other stars. How is this thing reflecting light? And look, this is a picture from NASA from the rover, and this is a picture from Greenland. Do you see a problem?
See a problem? That's the same photo.
It's the same photo, and this is from NASA.
Really?
This is from NASA. This is a NASA photo off of their website.
But you see, this is what's fucked up. So why would they do this? What do they have to gain?
Why the lie?
Yeah, because now, I mean, there's actually, before we get to the lie, because now I'm curious. So the way I understand, because you said you don't think we're moving, right?
I know we're not moving.
Okay, so the question I'm sure that people ask you is about gravity. What do you believe about gravity?
Good questions. Let's answer those two, and then we'll get into why the lie.
Yeah, exactly.
So NASA tells us because of the spin of the Earth, it bulges at the equator because of the centrifugal force. Well, if that was true, they say the water bulges 14 miles high. Well, how come Africa's not underwater if that's the case? Right? We're spinning, whirling, twirling in 4 different directions at once. The equator bulges 14 miles high, which is like, if you're in an airplane, you only fly about 5 miles high. At what point do you climb an extra 10 miles just to skim over a hump of water? And the answer is never.
But why would you skim over? Isn't because if you're going over the globe, in reference, you're still at the same, if you're gaining altitude.
But they say that the water bulges 14 miles high. So, if it's bulging, that's a bulge. That's not the perfect cue ball globe. How do we have lakes that are perfect mirrors? How is that possible on a spinning, whirling, and twirling world? We're accelerating. Curvature is accelerating. When you make a turn, like get a dinner plate, fill it with water, go in a car, get on a perfectly straight flat road and go 100 miles an hour, just 100. Fill the dinner plate with water and then try to take a turn. Okay? What's going to happen to that water? It's all gone. It's all going to come right out of the plate. The slightest turn whatsoever. And we're swirling, whirling, and swirling in directions that at speeds you can't even imagine. And we have lakes that look like this. Makes zero sense. Let's talk about, though, distances. You like numbers?
Yeah.
Right? Without using your calculator, without Googling, and I'm going to offer you a Bitcoin if you can guess it within a week. How long is 1 trillion seconds?
Oh, I don't know.
You want to take a guess for a Bitcoin? Come on.
1 trillion seconds.
1 trillion.
I don't know, a year.
Seconds.
I don't know.
A year? Yeah, you're very close. 31,000 years. Okay? Okay? So that's friggin' a lot, right? The closest star is the closest one. Okay. 25 trillion miles away. So if this was the sun, the heliocentric sun, gigantic, and it was a mile overhead, we'd look up, this is all we'd see. We'd see the entire sun filling the entire sky, horizon to horizon.
But it's not a mile overhead,
No, I'm just saying, for example, right? But then if we move the sun, like if this was the sun in the sky, right? It's filling the entire sky because it's really close. And then we move it away, it gets smaller because of perspective, right?
Okay.
And it becomes the size of a coin held at arm's length.
Okay.
Right? You hold up a coin, it's about the size of the sun. Okay. So it reduced from the entire sky to the size of a coin. If I doubled the distance, scientifically we can prove that its angular size would be too small to see at just double the distance.
Okay.
If I made it 8 times farther, you could be 1,000% sure that you couldn't see it. 8 times farther is a light hour. And the closest star is 4.5 light years away, and the other ones are magnitudes farther.
Yeah, that's why they're so small.
We just proved at double the distance of the sun, we couldn't see it. And I
don't know. I mean, look, at double the distance of that, wouldn't it be half of what we see there?
Well, it went from the entire sky to a tiny little circle. And if we went 8 times farther, you can do the math and you would see that its angular size is far below what your human eye could see. The eye has a resolution limit of 0.02 arc degrees, and you couldn't see it. That's a light hour. The next star is 40,000 times
But
farther.
what does this prove, though?
This proves that the stars that we see are not these giant gas balls burning in a vacuum.
So what are they?
How do you have a gas ball in a vacuum?
What are they?
How do you have a gas ball? You know what? Again, anything above our heads is out of limits. I don't even think NASA knows what they are. Okay. I think they have to do with our souls. I think our souls are in the heavens above and we're having a physical experience here. Right. And that's just my belief. Right.
Because it's that stuff that's fun to talk about and say, but then we leave kind of like the math realm, the let's try to calculate stuff, and we go into mysticism.
Well, I don't want to go there. Let's say, physical. Here's a map that was found, a Japanese map. It was in New York, the New York Journal, which is now the New York Times, showing like 50 other continents outside of Antarctica. We don't know what's out there because it's off limits. Think about this. They had in 1946, they discovered, the ice barrier in Antarctica, and that was interesting. And then in 1955, they had Operation Deep Freeze, where they discovered the firmament. In the Encyclopedia Americana of 1958 edition under Antarctica, it says that 80 degrees south, the dome cover is at 13,000 feet.
What do you mean? There's a dome?
There's a dome over us. Yes. What is it? Is it physical? Is it energetic? I don't know, but there's lots of information about that.
About a dome.
About a dome, absolutely. The firmament. Page, I'm not a religious person, but page 1 of the Bible talks about God separated the waters from the waters and created the firmament. Then they created NASA to hide the dome. Then they had the Antarctic Treaty, where all countries were out there killing each other.
But what about the Russians? They're in space too. The Indians, the Chinese don't like NASA.
So hang on. There's another good question. Hold that question. So in 1959, all the countries, Russia, United States, China, everyone signed on saying nobody can explore Antarctica, even though Admiral Byrd said there's land bigger than the United States, filled with resources that no one has ever set eyes upon beyond the pole. How do you go beyond the pole? And to this day, since 1959, it's still in effect. It's still in effect till the year 2041, and it can't even be questioned until then. Okay. Why did everybody agree? Why is this the only treaty that has held up the test of time?
You tell me.
Yeah, I'll tell you. 1962, we had Operation Fishbowl, where they started blowing bombs up in the sky, trying to blow a hole in the dome. And then they had the Apollo missions to hide the entire thing, to hide the dome, to make you believe you live on a ball.
But why, though? I don't understand why. If we lived in a dome, why not just say that?
Yeah, I'm going to get to that. What was the other question you just had?
We never talked about gravity.
Yeah, gravity. Right, but really quick, Russia and China, all of this division by countries is made up. It's all made up. There was no one died in the Cold War. Nobody. Just the military-industrial complex got bigger, right? These are fake. These are all staged bankers' wars, right? They know that they can't kill people. They're not allowed. They know the karmic impact of that. So they convince order followers to kill other order followers. If you signed up for the army and there was a war, they'd send you over there to go kill other people that signed up.
Right.
And why are you killing that person? You have no idea why, because you were told to.
I'm with you there.
Yeah. So why the lie? Is that where we're at?
Oh, no, gravity. Yeah, gravity's important to me.
Gravity is the most important thing that they have. So we live in this, the only true forces of this world are electricity and magnetism, and they're brother and sister. They go together, electricity and magnetism. And the world is set up like a giant battery where the salt water carries the current, the sun and the moon are the cathode and anode, and the land is the salt bridge of the battery. There's free energy. The Earth that does not move has a measurable, testable, provable negative charge to it. And when you lift up off of the Earth, there's voltage in the air. There's at a 1 meter, there's 100 volts, and at 2 meters, there's 200 volts, and it goes up from there.
So wouldn't we get electrocuted in airplanes?
Well, hang on. That's what static shocks. There's all sorts of stuff. We are electrical beings. We're grounded to the earth. But when anything lifts up off of the floor, it has a positive charge to it, and the earth will attract it. The negative charge to it will attract it down. It says down is down for everybody. Up is up for everybody. Left and right, forward and backwards all depend on which direction you're facing. But down is down for me. Down is down for somebody in Australia.
Right.
It's not up.
No, it's not down. But nobody ever said that. It's
well, no, because people believe if you're in Australia, from my point of view, cruise ships and oceans and people are all upside down, right? That's nonsense.
Oh, but upside down, I mean, on the globe, upside down is just arbitrary in the sense that it's where you're facing, but you're never actually upside down because we're all in space. So,
well, from my point is,
yeah,
I have to believe that right now, according to where I'm standing, there's a cruise ship upside down in Australia.
Oh, yeah, in your reference point. Yeah, exactly. And gravity is keeping him up on the same.
And so we'll get into a little bit. But here's a tinfoil triangle. You can just look this up. You put a negative charge on it, and it lifts up off the ground. It's not defying electricity. Its negative charge becomes stronger than the Earth's, and it goes up. Okay. Buoyancy and density sort everything else out. If I had a handful of marbles and ping pong balls and held them over in the air over a swimming pool, I dropped them. They'd both fall through the air because they're more dense. The ping pong balls would float on top of the water. The marbles would go to the bottom.
Well, they'll all fall. They'll all fall. And they'll
all fall because the earth is attracting them.
Right.
But then the water is more dense than the ping pong balls. So the ping pong balls will stay on the top. And the rocks are more dense than the water. So they'll go to the bottom. Buoyancy and density sort everything else out. And the earth has a negative charge.
But if there's no water and they're falling on land, no matter what,
just sit on the land. The land is more dense than ever, and they'll sit on top of the dirt. If you had a,
but isn't that mass? Isn't masses always attract masses?
No, that's a theory, and no one's ever proven it at all. They have the Cavendish experiment where a guy had 2 lead balls in a barn, and there's so many things wrong with that experiment that even the Globers don't use that experiment as proof anymore because it's ridiculous.
Don't they make people study that, like, to do it themselves?
Yeah, they do. They make people study it, but it's dumb and it doesn't work. And you have static charges, you have all sorts of biases, let alone a tiny breath of air could change everything.
But wouldn't things fall at different speeds? Because right now we know the speed in which a physical object will fall.
No. Things fall at the negative charge, their density. Like if I dropped a 5-pound weight and a light ball, the ball would fall slower because the weight would just pound through. Things fall at different speeds.
Because I thought the force of 9 something
9.8 meters.
Yeah,
per
9.8.
second.
Yeah,
that 9.8 meters per second is, if that's correct, then that's what the negative charge of the Earth creates. 9.8 meters per second.
So then aren't you saying the same thing? We're just choosing a different name for gravity.
Well, there's no proof that mass attracts mass. If that was true when you're standing next to Mount Everest and you hold a plumb line, it should be a little crooked, but it's not. There's no amount of mass that attracts anything. And then there's a problem. It's called the 3-body problem. So to believe in the heliocentric model, you have to believe the Earth is falling around the sun. So we have the sun and the Earth is going around it, right?
Yeah, and around itself.
The sun's gravity is holding on to the Earth.
Yeah.
And then it's also holding on to Mars, Saturn, Jupiter.
Right.
The sun's holding on to all of those distant planets.
Yeah.
But somehow the Earth is holding on to the moon. And the moon is circling around. And the other planets are holding on to their moons, multiple moons.
Yeah.
When the moon goes in between the sun, how come the sun doesn't grab onto the moon and pull it away? How come when the moon is coming around the Earth towards the sun, it doesn't speed up and then slow down a little bit? How come the sun's gravity ignores all of the moons and only holds on to the planets? How come when we have planetary alignments, all shit doesn't get fucked up? And let me tell you about the 3-body problem.
Yeah.
You can take the world's best supercomputer and you put a mass. You say, all right, here's the sun. It's got this mass, it's this size, it's got this much gravity. And then I got a little planet. I'm going to put it in there. I'm going to set them in orbit. And the computer will render that all day long. You can figure out exactly where it's going to be. It'll work perfectly forever, right? And they can do this. Then in that computer program, you add one more body, either a moon or another planet orbiting either one of those bodies, and the entire thing goes into chaos mode and never repeats.
Look, it is pretty crazy. It is pretty magical, but I'm trying to think now because I don't know enough about why the moon's not pulling away. I'm assuming it's because it's pulling towards the Earth. We're the closer body, and that's the mass that's being attracted.
But the sun is also able to hold on to farther planets. How come when things line up, there's not, how come the sun should tug on the moon?
I don't know why it should, though.
Well, because it's gravity. It's holding on to things.
But it might. Holding on. We're still rotating, right? So it could be holding on while, we just don't understand exactly how it's working.
Rotating, but you have no proof of that. You talk about buoyancy and density. Look at this thing. This is 40,000 pounds of steel falling from the sky. It's supposed to burn up before it gets to those clouds, but in reality, this is a helium balloon. This is filled with helium. It's not steel. They want you to believe this is the external tank from the space shuttle, but why isn't it falling? Why is it floating? See a little piece of paper flew by it? That's probably from one of the helicopters. Dropped a handkerchief or something.
I don't understand what this proves.
This proves that this isn't falling. This is, gravity doesn't. I actually jumped forward. This is from the space shuttle. And the space shuttle it's all a ruse. No man has ever been on a rocket to go into space. Yeah, some evil Knievel shit, going maybe 1,800 feet in the air, but that's it. All those rockets, they're not manned spacecraft.
But again, so why though? Now let's go, I guess, to the why, because
why the lie?
Yeah.
So what is your do you have any religious beliefs, spiritual beliefs?
I'm Greek Orthodox, so Christian.
Okay, awesome. So if you look into the Bible, there's over 200 verses in the Bible speaking of a flat, non-moving earth. The Bible literally is a flat earth book from page 1. But the people that have taken over this world, which happened, I believe, in the late 1800s, early 1900s, hate the creator. They don't want people knowing who they are. They want you to believe that you're spinning out of control on a tiny speck with trillions of other specks in a godless or distant god, infinitely expanding universe where an asteroid could take you out at any time, where you have no control over anything. You're spinning out of control, lost in space. Versus the truth of the matter is that you are very special, that you are at the center of creation, that you are a powerful spiritual being, that nobody has dominion over you, that your thoughts create your reality, and nobody can break your free will unless you
see, this already, what you're showing now doesn't make sense to me. Already, just the way the sun, I don't like that in the middle, it's shorter the distance that the sun is covering from the other side.
Yeah, so again, the optics of how it works. Let me, since you brought that up twice, let me bring up a quick video for you if I can.
Yeah.
Where is my clock? How come it's not? There it is. I think this is it. There you go. So if we go to the frequently asked questions and we say, where does the sun go? I think, what about seasons? Where is it? Maybe it's in what about seasons? Nope, that's not where it is. Where does the sun go? Maybe that's where it is. I want to show you how day and night work. It's in here somewhere. So it all has to do with the position of the sun and the moon, and how close they are to the dome. When you're near the dome, maybe it's southern.
Are they inside the dome or outside the dome?
So the sun that we see is inside of the dome, but I believe that the true sun is within the waters above. And we're literally seeing a projection when you use a magnifying glass to burn ants when you're a kid. If you lift the magnifying glass up in the air a little higher, that dot is not on the ground anymore. It's in the air. And that's kind of what the dome does, focusing the sun's energy into our realm. But I can't pull it up right now. Okay. But when you, when the sun moves out towards the dome, the light wraps around farther. And when it moves in towards the Tropic of Cancer, when it moves in here, the sun becomes more of a circular light.
But does it?
And we have.
But you see, this is what I find, because I remember when you're looking at the tropics, so they're different. They're different lines. They're different sizes, right? So observably, to go over those distances, wouldn't they have to go different speeds?
Absolutely.
Because throughout the year, the sun doesn't speed up.
It doesn't, but it just like it actually does speed up, because it's on. It goes around its angular speed doesn't change, but its speed does change. So if you were standing in a room and you had a flashlight and you pointed it 3 feet in front of you and you turned around at the rotation of 1 minute to spin around, and you drew a circle, that circle is going to be 3 feet, a 6 foot diameter circle.
Yeah.
You point it 12 feet away, turn around at the same rate, you're going to still complete that circle, but that's now a 24-foot circle. Right.
I see what you're saying, but
a bigger circle.
But
it's going faster.
So you're telling me this is moving between tropics and going higher, lower. But what's causing these changes?
Well, that's those are coming from the heavens above. I can't answer that.
Okay.
But the answer is at certain times of the year when the sun is out towards the Tropic of Capricorn, like in Central Africa. When the sun, where are you? What state are you in?
I'm in Canada.
All right, so in Canada, well, it's probably not as drastic for you, but in Canada, in June and July, when the sun sets, how long is it still light out?
Oh yeah,
good hour, right? Yeah, good hour or 2 hours, right? In the middle of summer, right? In Africa, certain latitudes in South America, when the sun sets, 5 minutes later, it's pitch black. And that's because the sun is going faster. It's moving faster. But why don't we see it move faster through the sky? And the answer is, I'll show you a quick video.
Yeah, because if it's not, shouldn't it be observable in science, in life?
Yeah. So this is what we call the personal atmospheric dome. The way we see is we're like each person standing in the middle of this dome, and this is how we see the sun. So this point right here is where we see the sun. So right now, it's nighttime over here, but the sun is still here. And now it's coming back. I'm going to stop the sun right in the middle. So it's noon here, right? It's a little afternoon here. It's late afternoon here. And this is where you see the sun. It's called your personal atmospheric dome. And it's a lot to understand, but once you start seeing,
that's a little crazy though.
Yeah. So here's a glass dome I just have it on top of a white rug, and I'm moving a light across it. So the real sun is above the dome, and inside the dome, this is what I see.
Yeah, I see what you're saying. Yeah, it's
rise and it sets, and then it never really sets. It's always perspective. It's the atmospheric density that makes it set for me, right? It's like when you're watching the sun go away, it's just going away. It looks like it's setting behind this cloud, but it's just going beyond it. But the next, at 20, 30 miles away, the clouds merge with the horizon, and the sun just goes beyond it. It just goes beyond it. But on the high plains of Africa, this shows you this is sped up. The sun's not going down. It's just going away.
So wait, the moon is what though? Is the moon a disc to you too, or a ball?
Yeah, the moon kind of looks like a ball, doesn't it? But when I say, you have lights in your ceiling?
Yeah.
We are right now. So look at your lights and tell me what shape the floor is.
What do you mean?
Well, that's what I mean. It's a ridiculous thing to do. Look at, if the moon is a sphere, it kind of looks like a sphere, but we can't prove it's a sphere. For example, is that a sphere? Well, it's a half a sphere. Is this one a sphere before she grabs it? Is that a sphere?
I don't know. Looks like an onion.
Looks like a sphere, right?
Yeah.
It's flat.
Okay.
Is that one a sphere?
But it's preposterous to bring this up as opposed to the moon, because
no, what I'm showing you is that it's not fair to look up and say, well, that looks like a sphere, so therefore the Earth is a sphere, right?
No, but I'm not even talking about the Earth now. We've got past that because you've.
I mean,
fully.
It's to say the moon is a sphere.
I'm asking, what is it to in the flat Earth model? What is the moon?
I don't know. I think I think it's plasma. I think it's not a physical object because you can't triangulate the moon. If two people try to triangulate the sun or the moon and add a third person, which should make it better, everyone's seeing it in a different position. It's kind of like if you and I were standing outside 50 yards apart and there's a giant mirror, upright mirror, and the sun was setting behind us and we're looking at the mirror and the third person went up to the mirror and they said, I see the sun right there. And they drew a circle around the sun where I see it. They're going to draw a circle 50 yards over.
That's fine, but it doesn't change. It doesn't change what the sun or the moon is. That's why I'm asking, what is the moon in this?
I don't know, man. The moon's the biggest mystery of all.
Okay.
Nobody knows. I don't even think the people at NASA know.
I'm just thinking. I'm looking at the video that you're showing right now. Is that the sun?
Yeah. Again, we have pilots that fly from long distance, one from California to Germany. And we had a pilot on from KLM who told us, how the gyros work, how the plane never noses down, and they don't have to worry about curvature or spin. And they see the sun and the moon and they don't set. And it's, how it's impossible. Next day, by the way, she was grounded and then fired. Okay?
But I understand why they would account for curvature in the sense that, the plane is flying, right? Why are we assuming that it would hit water? I don't get it.
Well, you're not because a plane flying at 550 miles an hour or whatever speed, that's the average speed of an airplane, would have to account for curvature because over the course of an hour you'd be 30,000 feet higher. Okay, not 30,000 feet, 30 miles high.
Oh, if it was just doing a straight line like this is what you're saying.
It was doing a straight line, and gyroscopes hold rigidity in space. The pilot fires up his gyroscope on the runway, and so then the plane's going. When the plane turns, the gyroscope stays level, so he knows to go back to level. And when he goes up, the gyroscope he needs to go back down, and the gyroscope holds rigidity in space. A gyroscope would send you all right off into space.
Well, no, because wouldn't it be based on the Earth? Wouldn't it be based on?
It's not based on the Earth. Gyroscopes ignore gravity. They only they hold rigidity in space. No matter which way you turn, the gyroscope on its 3-axis gimbal will hold its rigidity. So you would have to mile down a mile, on average every 2 minutes.
Yeah, I don't know. I don't know. I'm not good at this. I don't know how true this is, or I'm not a pilot.
Well, again, you gotta look into it. There's many pilots that have spoken out saying they know the Earth is flat and doesn't spin. Think about this: if you're on the Earth at the equator, you're spinning 1,000 miles an hour because it's 24,000 miles around. 24 hours, 1,000 miles an hour. But if you're all the way up at the North Pole, just like a mile from the North Pole, your little circle around that North Pole is only 3.14 miles every 24 hours. So you're going like an eighth of a mile an hour. You're not even going 1 mile an hour up there.
I don't think that's how that works.
Well, that's exactly how it works. Because if you're spinning, if you're sitting on a runway here, and then I was watching you from space, you're going to travel, you're going to make a circle 24,000 miles around in 24 hours.
Right.
If you're 1 mile from the North Pole, and I was watching you from space, you're going to make a circle that's 3.14 miles.
Right, but I'm still spinning at the same speed. My circle's just smaller.
You're not. No, you're going the same angular speed, but you're not going the same miles per hour.
Well, hold on a second, because let's say you're on the runway, you're on the ball, right?
Yep.
Wherever I'm standing on the runway, you might see me closer or further, but if the maintained speed of the runway is one speed, let's say it's X, I'm always going to be going that speed. But depending on where I'm standing on, obviously I'll have a different perception of how far you see me, but the runway is going the same speed. Like the globe is going one speed. It's not going different speeds.
Yeah, it's going different speeds. You're incorrect. The angular speed is the same. You go 360 degrees every 24 hours. But if you're a mile from the North Pole, you travel 3.14 miles in 24 hours. If you're on a runway in Ecuador, you're traveling 24,000 miles. You're going 1,000 miles per hour. Okay. If the airplane took off from the North Pole and tried to land on a north-south runway that's moving sideways at 1,000 miles per hour, where's that airplane going to get that extra 1,000 miles an hour of speed to land?
Well, okay, I see what you're saying, but aren't we projecting, for example, like when I jump in the air, but you're saying you don't believe that we're moving at all?
We're not. I mean, do your senses tell you you're moving? Because you've traded in your senses for nonsense.
I don't know. It seems to make sense.
What makes sense?
That we are moving, yeah.
What experiment? What scientific proof do you have? By the way,
the observable universe around me.
Scientific experiment that is checked for axial rotation or curvature has failed all over time, but they don't teach you that in school.
Really? What do you mean? Like this, I want to look up.
There's all sorts of scientific experiments to prove that the Earth is spinning, and they all failed. And they proved that the Earth is stationary and that the ether is spinning above us.
Okay, this I'm going to look into after this because I'm curious.
Aries failure, the Sagnac experiment. There's a whole bunch of them.
Okay, so again, so right now, so we don't forget, because I guess the main takeaway would be, if all this is false, the main reason for it right now, you said, would be that they don't want us to know our true selves.
They don't want us to know our true power, because if you wake up and realize that no one has dominion over you, they lose power. We're literally plugged.
But how does this put dominion over us?
Well, do you obey the government?
I'm not a fan of the government.
What's that?
I'm not a fan of the government.
Do you give them a third of your salary or more?
More over here, forcibly. I don't want to do it.
Yeah. Well, what if you found out none of that was allowed? What if you found out that you are a free, sovereign human being and that you didn't have to obey anything they say, and that there's more? That there's more. There's no shortage of food. There's no shortage of water.
But where does this come into play? Where does the flat Earth come into play to this? How would that change?
Well, it's not the shape of the Earth that matters. It's a lie. They don't want you knowing who you are. They don't want you knowing your true power. They don't want you knowing that your thoughts create your reality. Your thoughts, everything you have in your life is because of the way you think.
You mean in terms of motivation and doing it?
Everything that you have. Everything you have in your life is you thought it into existence. You brought it into existence with your thoughts. Okay. And there's people that live paycheck to paycheck their whole lives. There's people that make millions of dollars and then they lose millions of dollars and they're millions of dollars in debt and then they make millions of dollars again. That's just because of the way that they operate. There's people that, everything in your life is because of the way that you think. You are your only enemy, and nobody can take your God-given free will away. Nobody can take it away unless you willingly give it to them. And they constantly put us into fear. And when you're in fear, you can't get that power. You can't use it, and you willingly give it away.
But I'm with you on them constantly putting the fear, but I don't understand why they would need to lie about the globe to make that happen.
Because there's a verse in the Bible that basically says, if once you see my creation, which is the earth, you no longer have any excuse to deny my existence. So they don't want people in a situation where they can't deny the creator. So they have you, they want non-God believing, scared people that think there's shortage of food. There's no food shortage. There's no water shortage. There's no energy shortage. This whole extracting oil from the earth is not the way, there's free energy everywhere. They don't want us knowing any of that, right?
But wouldn't they have to, teachers, scientists, pilots, wouldn't everyone have to be in on this?
Absolutely not. The teachers are the ones that can memorize and regurgitate all of the nonsense the best. If you can memorize and regurgitate and believe the nonsense in the textbooks, you become the next teachers. Pilots are just following their GPS is flying the plane. They just land and take the plane off, and they don't question it. But the ones that do are waking up. There's thousands and thousands of pilots that are awake now, and they're waking up more and more. They don't want this awakening. They're doing everything they can to stop it. And I think a lot of what's going on in the world right now is to reset the memory of everybody. It happens every 100 years. They pull the same nonsense again every 100 years, and they're trying to do a great reset. Okay.
I feel like we're jumping on different things because I've heard of the Great Reset too, but I don't know. Again, I don't know how any of this would apply to the Earth being flat. Like I don't see, because you can believe in God and believe in the globe.
Can, but you're missing half of it. And there are a lot of people that do believe in God that are fine, that are doing well. But if the majority of the world is lost in space, thinking that they're insignificant, not knowing their true power, then they're not exerting their true power. It's literally, the movie with Keanu Reeves, The Matrix.
Yeah.
So at the beginning, he's kind of depressed. He's trying to something's wrong with the world. He can't figure it out. He's depressed. It's because his mind is in the Matrix. He doesn't know where he is. By the end of the movie, he's unplugged from the Matrix metaphorically, and he's taken back his power, the power of his mind. And now his life is different.
I agree with you there. Taking responsibility and taking power. I agree with you on that. I just don't think that everything is, just because there are lies being told and there are definitely conspiracies, real conspiracies, they conspire against us a lot. I don't think that everything is a conspiracy. That's where I feel like sometimes it's easy to fall into that, where they must be, they must be lying about everything.
Again, that's not me. I just want the truth, and I went into this trying to disprove it.
I'll tell you one thing about you that I know from talking to you now. I don't believe that you're like a purposeful con man or anything like that. I do believe that you genuinely believe. I don't think you're saying things because you're trying to deceive people. I genuinely, from talking to you, believe that you believe.
Okay. Well, here's the question I have for you. Why do you believe it's a globe? Besides other people told you and you can't believe there's a lie that big that can be kept secret.
Yeah. No, I believe that there's pretty big lies. I don't think that one can be kept secret. It wasn't, obviously, I grew up understanding that it was a globe, so it makes it easier to maintain the same belief. But just like, I grew up Greek Orthodox and you were bringing up the Bible and stuff, but I am well aware that a lot of what was written in the Bible was either misunderstood or horseshit that came out, through the years of people we were writing, like a lot of textbooks are. Like I said, I've just in school and even now I was trying to study it, and the flat earth model as opposed to the globe earth model, it doesn't make sense to me, the flat earth model. That's why I was asking questions, because I was trying to figure it out. But even the same thing with gravity, the way I understand gravity, the way I understand force, it feels like it doesn't fit in with the flat earth. It's not even a question of I'm dismissing it because I don't want to hear about it. I'm actually trying to hear about it, but it doesn't the dome over us and stuff, it seems ridiculous.
Well, it seems ridiculous because you don't understand it yet, but once you do, you'll see. In the app, in the Flat Earth, Sun, Moon, and Zodiac Clock app, if you hit Biblical Flat Earth, there's all of these videos here. If you just start watching some of these videos, then you'll start to really understand what the Bible is saying and what this place is. Again, you're not gonna figure it out on this podcast.
Right.
The question is, I pointed towards a whole bunch of doors. Belief is the enemy of knowing. What's my name?
David.
What's my name?
David.
You believe that? Do you have any proof of that?
Well, that's what I'm going with.
You're going with it because you believe me. You're looking at me. You're like, I believe this guy. Belief is easy because boom.
Yeah.
But if I'm talking about to find out if that's really my name,
right,
you could probably do it in a couple of hours, maybe a couple of days of research. But nobody wants to do that. People want to just believe. We were taught the earth is a globe before we can talk. All of our schooling was about dinosaurs and asteroids. And, as little kids, the globe, the first worksheet you brought home was about the earth goes around the sun and the moon goes around the earth. It's all about globe programming. They've put it into the foundation of our world. I am ripping that belief out from underneath you, and I'm putting you on a true foundation, the earth. Go outside and meditate and imagine all of those spinning, twirling, and whirling motions, right? And then shake your head off and imagine that you are centered on the basement of the universe and you're not moving at all and the heavens are turning about above you. Immediately you feel your energy rise. You'll feel your soul be like, yes, hello. Your soul's been trying to talk to you. You're depressed, like Neo. The reason people are depressed is because they're lost. They don't know who they are. And their lives are falling apart because of their thoughts. They don't want us to know that our thoughts create our reality. That's the bottom line. People
are depressed, and it is important for people to actually create their own reality and this, take responsibility. But I don't think that the earth is flat. Like, I'm trying.
Well, what's your one proof that the earth is a globe? Just one. I'll give you a Bitcoin if you have one.
Oh, well, for me, I have like I said, when we're looking at the night and day cycles that it's showing there in the map. Also, I know that there's flights from South America that go directly over the Pacific to Australia. So it's not that
they go like this. They go from Santiago all the way up here across and then all the way back down. Why do they go all the way up to the north across the equator? And if you want to go to Western Australia, they go all the way up, all the way over to Europe and Dubai and down. And the reason is because here's going to Western Australia, all the way up across Europe, Dubai, and Western Australia. It's a straight line. Okay. These are the paths that they take. They only work on a flat earth map. There's no reason why they wouldn't just cut around Antarctica. Right. Antarctica on the globe is 13,000 miles around. An easy way to prove the earth is a globe is to get two ships, put them within sight of Antarctica. One goes this way and one goes this way. And then they should meet 7,000 miles later on the other side. But they can't do it. One, you're not allowed to go within a couple thousand miles, beyond 60 degrees south. And two, the last person that did it was Captain Cook, and it took him over 3.5 years. And he went over 60,000 miles, and he never even completed his journey. Okay? And that's because the Earth is not a ball. Antarctica is not a continent at the bottom of a spinning ball. There's no pictures of Antarctica from space, because that's another thing that doesn't exist. The whole thing with satellites and space, it's all nonsense, all of it. And once you wrap your mind around that, then you'll start seeing, and things do change. People say, what difference does the shape make? I still got to go to work tomorrow, right? All of that changes. Right? My whole world changed. I had my own company. I was making large six figures. All as well. I walked away from it all.
Because of the flat Earth?
Yep.
Come on, David.
I walked away from it all.
Couldn't you have done it all at the same time? Couldn't you have been looking into this?
I couldn't. I couldn't, because this is unbelievable. This is actually harder than my company working, for myself was. But if the world is in chaos right now, and you can see what's happening, the elite are trying to take over with communism, and if somehow we get our freedoms back, how long will we keep it if we're lost in space, spinning out of control? How long? Not long at all. Okay, so the answer is it matters. It totally matters. Who you are. So here's the thing. To wrap it up, don't believe anything I say, even my name. Right? Don't believe any of that. And I
believe in your name. I don't believe the Earth is flat.
Well, but you have to ask yourself, what's the one proof of the globe? I'm offering a Bitcoin that's like $60,000.
But what do you determine as proof?
Well, anything. Show me curvature. Show me, show me somebody that crossed Antarctica. Show me a flight from Santiago to Australia over Antarctica.
But because I was looking now to see there's but because of COVID they won't give me all the details. But it looks like there's flights like from LATAM airline Santiago to Perth.
Yeah, it goes all the way up through the north, and those direct flights, we tracked them. We actually, Max Egan went on it, and we did a 14-hour live stream, or maybe it was even longer, where we tracked him through the airport. He live streamed with us. When the plane took off, he was taking compass readings, and the compass readings made no sense on the globe. They made perfect sense on a flat Earth. By the way, in the app under Antarctica, under Southern flights, all of that information is there. You can watch it. Here's the thing.
But how does a compass work if there's no... there's no globe.
Very good question. So the center of the Earth is the North Pole. We believe there's a magnetic mountain there. There's a magnetic force. You put a compass down, the north needle will point to it. And if you try to go west, you have to keep turning to keep that needle pointed to the center. So when you dead reckon west, you're going in a circle. You're going in a circle, and that's the same on a flat Earth and a globe Earth.
But then what's south?
South is every direction away from the center. Okay. South is every direction away from the center. So if you try to dead reckon west, right? I'm going to dead reckon west. And if I don't keep turning to the north, that compass turns, and now I'm heading south. South is every direction away from the center. And when you go south, you don't come back. Okay. East and west are circles. Okay. So I'll show you again. On the app, if I turn on the compass. So
this is what we're looking at now is the flat Earth map. This is what flat earthers believe is the actual Earth map.
Correct. Now, some people believe that there's different. We're still trying to figure it out. This, by the way, this is the map that the United Nations uses. Right? This is the map that's on Air Force One during the wars when Kennedy was on Air Force One. There's a picture. This map is on the wall. This map is used everywhere. But
well, you can't, because it's just the globe flattened out. That's why they use it, right?
No. The globe is just the flat Earth map wrapped around it. Okay, so it all depends on your reference frame. But if I leave Miami and I head east is a circle. And it brings me right around. I could dead reckon 90 degrees. I think I'm going straight, but I'm not. I'm just coming back. West brings me all the way around, all the way back to where I started. I can even go north. If I want to go to Japan, I can go north. And as soon as I pass the magnetic center, I'm now heading south, and I'm in Japan. I can also go west.
But that's
and end
not
up
what
in
happens.
Japan.
Like, let's say
I
with
can also
flights,
go east and end up in Japan. Okay.
like for example, with flights right now, wouldn't a flight from New York to Tokyo be a quick cut through? The way I'm looking at it now, going north.
New York to Tokyo. So
Yeah.
let me turn that off. So New York to Tokyo. So New York
Yeah.
to Tokyo, you can go. This is where they go. They go to Alaska, and then over to Tokyo. This is basically, it's a straight line. You could also, if you want California, sometimes they'll go around this way. Sometimes they'll go up straight. But the reason that Alaska is such a major hub is because this is how you get from the Far East to the United States. You got to cut across here. Nobody's allowed to fly over the Arctic. Think about this. Words have meaning. If I'm standing here in the Arctic, right? And I turn, and the sun is, what is the sun doing? The sun is, so I'm here in the Arctic. The sun, what's the sun doing? It's arcing around me, right? It's arcing around me. Agreed?
Yeah, but you see, even now, look at the model that we're looking at. Look at the moon. The moon, it's making a unproportionate night. It doesn't make any sense.
No, the moon doesn't make night. The moon's in the day sky.
I know, but look at where the sun is, and look at where the light of the sun is going, and where the moon is. It feels like they're not proportionate. It doesn't make sense.
Well, one, it's not proportionate, the size of the moon, but the moon has.
I mean, the amount of light that the sun is covering and what blocks it. Like, why is there an arbitrary line in the middle if it's flat? So what's blocking it? Why is there a straight line that moves forward? Because we're talking about light.
Yeah. So you asked that question, and it's hard for me to explain. But when you move the light towards the outside towards the dome, it wraps around. It's
right. But so right now we're saying that it's going up and down through the tropics, and it's going in latitude. It's going higher and lower.
I didn't say it's going higher and lower. I just said it's moving outwards and inwards. It's called the analemma. But let me my point that I was making
sorry.
about the sun. So in the Arctic, the sun is arcing around us, right?
Okay, so that's why you're saying
if you're looking at it, it's making an arc around you. Okay, you got that. But if you're out here in the Antarctic, what's the sun doing? It's not arcing around you; it's antarcing away from you. Okay, Antarctica, Arctic, Antarctic. Right? That's what it's talking about. It's all about the sun. Airplane, not air globe. Sea level, not sea curve.
So well, the other words are funny, but what would the ancients who were measuring, what would their agenda be in thinking that there's a globe Earth? Like, why would they be part of this?
Not one of them was. You're believing stories. They were all flat Earth cosmology, all of them. By the way, in the 1920s, everyone knew the Earth was flat. They were teaching flat Earth in the public schools in the United States all the way into the 1920s, right? And in the
that's why the crash happened right after.
Yeah, well, that's all of these wars and the Depression. All of this stuff happened to change history, right? I interviewed a woman named Ruth, 102 years old, in February of 2020, and she had such a great memory. I was talking about the World's Fairs, and I asked her what they taught her in elementary school. I'd never mentioned flat Earth, and she said they taught me the Earth is flat, right? But then they changed it years later, and she just believed it because she lived on a farm. There was no electricity. All sorts of stuff was happening. Electricity was just coming.
I know, but back then they believed black people weren't even people. Like I don't, if they believed a lot of stupid shit back then.
Yeah, well, that's again another story. The whole friggin' Wild West is all another story. There was an advanced civilization here called Tartaria, right? In the 1800s, there was giant ships in the sky, bigger than aircraft carriers, right? Cruising around the world. The world was a united place, and there was a cataclysm that happened, a mud flood of something happened, and when we came out of it, the people that came out on top decided to hide the rest from us. They're trying to keep their power. Everyone knew the Earth was flat, but until the Industrial Revolution, and so the elite changed it because they don't want people knowing what power they have. They don't want people knowing where they are. They don't want people knowing that perhaps beyond Antarctica is more land, other continents. Like that map I showed you from the New York Journal. What if in the outer space, in the extra terra, there was other people out here, other civilizations living out here with their own sun and moon.
I mean, it's fun story wise, fictionally, but again, even like I said, ancient Greeks had we still have statues of Atlas. Like they were aware that the Earth was
When were they made? Do you have any proof of any of that? Okay,
how do you mean?
Well,
like
I don't
maybe
anything before before the 1900s. It's all made up by the victors. The story of Aristophanes. He's the guy 2,000 years ago that discovered the shot that the Earth is a globe and the size of the Earth. Most famous mathematician. There's not a single mention of him in any book by anyone else ever until the late 1900s. He was inserted into our history, and everyone believes it's a fact. But it's a made-up story, and even if it was real, it works on a flat Earth too. They don't want you to know that.
What works on a flat Earth? His circumference calculation?
Aristophanes' calculations work perfectly in the flat Earth model. So, one, he never did it. Two, his buddy 500 miles away had, what, did he have a fucking cell phone? Or did he have a string and cup, you know? Okay, how did he communicate with them? How did they figure? It's all a made-up story just to make you believe you live in a ball.
But can't we calculate this today?
We have Stockholm syndrome. You've believed that you lived on a ball for so long that you will defend your captors until forever. So listen, we got to wrap it up.
Yeah. I know you have other.
Good.
I know you have other calls, so I don't want to keep you too much. I kept you extra on this one, but I do thank you for coming on. And if people are interested in learning more, where do they go?
So if you Google flat Earth, you can end up at the Flat Earth Society. None of us believe any of that nonsense. It's a government-run disinformation site. If you Google top 10 reasons.
So hold on a second. There's different sects. There's different sects of flat Earth.
It's not a sect. It's disinformation. It's like looking up cures for cancer. The big pharma will tell you there's no cures for cancer.
Yeah.
If you look up flat Earth, you end up Google will deliver you to the Flat Earth Society.
And these guys
not what we
are different.
It's not that there's different sects. That's bullshit.
Okay.
And we're not bullshit.
But okay? What is yours? If they're the Flat Earth Society, then what are you?
We're just flat Earth. We're just true Earth researchers.
Okay. I'm just saying, like, what's the naming convention? No,
there's no naming convention. I'm not part of any organization. I'm doing this on my own.
Okay? That's what I mean. So if anybody, they would go directly to you, because if they look flat Earth,
me, just figure it out. Here's what I'm saying is I created this app. Because when you Google flat Earth, you get all disinformation. You said, "Hey, Dave, send me something on the fake moon landings," and I sent you something. The next video that would pop up would be an anti-fake moon landing. It would be like, "Oh, look, watch this." Google's going to try to deprogram you. So this app with all of the links on it will bring you to only good content. You could spend, someone said, okay, you know what? I'm going to spend 500 hours researching flat Earth. You're going to find 2 hours worth of good information. If you made it through the 500 hours, the app will bring you to only good information, and then make up your own mind. Don't believe anything I say. Do it yourself. Like when I heard, okay, we can see too far, I looked up the curvature formula. I checked it out. And then I said, all right. And I bought a $1,000 camera and tripod. And I went down to the beach. I said, I know that buoy is 11 miles away. If it was 10 miles away, there should be 66 feet of curvature. I could see the buoy and I could see the land. I could see water surface for another 20 miles beyond it, right? Where there would be hundreds of feet of curvature, right?
Yeah, I guess latitude also plays a part.
Absolutely not, because there's Navy ships that can take a pencil-thin laser beam and light up another ship 100 miles away. There should be 6,600 feet of water in between them, but they can see them. A submarine near the bottom can send sonar out. Whenever it hits something solid, it bounces back, and they know how far it is, how big it is.
Right.
They can see another submarine over 100 miles away. Well, there should be a mountain over a mile high in between them, and there's not. What does sonar underwater climb over mountains? Okay. It can see too far, period. And then there's so many proofs. I mean, a vacuum of space next to a high pressure atmosphere breaks every law of thermodynamics.
Well, a space vacuum doesn't mean it doesn't suck. Like, it's not a vacuum cleaner.
I'm not saying, that's another program thing. No one ever says it sucks. I'm saying there's no pressure. If you had a bottle filled with no air in it.
Drink some water, Dave.
I got it. If you had a bottle and you
I don't want people blaming me for killing you.
I'm going down. If you had no air in the bottle and you opened it up, it would suck the air up and away. If you stuck the bottle underwater, just the tip of the bottle underwater and opened it, it would suck the water up and away. So that proves that low pressure can pull things up and away from gravity. How come the ultra no pressure of space doesn't suck the air up and away, right? And the only explanation is gravity and a pressure gradient. That's bullshit. I can take a straw with the weak vacuum of my lungs and mouth. I can pull water and air up and away from Earth effortlessly. But the space vacuum can't. It's nonsense. It's total nonsense. We didn't even get into space. Maybe if you let this digest, we can do another show, and I could just show you how NASA is lying about everything.
We'll do another show for sure. Now I'm curious about the space stuff.
Yeah. So listen, the app is $2.99. I'm the scammer trying to sell an app. That's all I'm trying to do. So I'm giving you all this bullshit, right? But an app is less than the cost of a beer or a Starbucks coffee that you're going to piss away in 20 minutes. You'll have it for the rest of your life. It'll serve you. If you don't believe me, just read the reviews in the App Store and the Android Store. The Google Play Store, by the way, your Android phone has to be 8.0 or higher, and iPhone, you have to have an iPhone 6 or better.
Yeah.
And then watch the daily video every day for 2 weeks. People say it's the greatest thing ever, right? And the app, you have it for the rest of your life. And just watch it, all the questions you have, and watch what it does for your life. It's amazing once you know who you are, where you are, what you are, and the power of your own mind. And the last thing I'll say, without saying too much, because I don't want to get you a YouTube strike, is don't let them control your mind with cartoons.
Right. I get what you're saying.
Right? It's all cartoons to scare you and make you believe in nonsense. Use your common sense and don't trade it in for nonsense. Don't say, I'm not a scientist. I don't know. The scientists are the ones that memorize and regurgitate the nonsense the best. And by the way, there's great scientists. Chemistry, very cool science, right? There is the people that make phones and computers. That's great science. Pseudoscience is NASA, is pseudoscience.
Yeah, we're going to get into it next time, too, because I want to know about the other space programs. Where do they fall into all this?
They're all in it together. Just go. So here's the thing. In the app, under if you hit the web button, there's one of the buttons says Flat Earth documentaries, Flat Earth feature length films. The first one in there is called 21 Questions. Flat Earth. Stranger's Guide to Flat Earth, 21 Questions. Watch that, and then you'll stop asking me questions because they'll all be answered.
Okay. Well, again, they're being answered sometimes, but I just don't. I don't know. I don't agree with it. However, like I said, I do not feel like you're purposely lying to people. I do feel like you believe it. So I think that's saying something. Thank you, David, for coming on, and I'll have you back on to talk about space next time.
All right, man. Thanks. See ya.
Thank you.
We've built this prison cell 'cause we can't trust ourselves.